on periodicity and its cause. So the learning objectives for this session include definition of periodicity, why and how periodicity is caused, and some basic terms which is very important to understand the cause of periodicity. And as usual, we'll have some activities to discuss. Now let us try to understand some basic terms to understand periodicity and its cause. So the first basic term we'll discuss is valence shell and then valence electron. That is the outermost shell of an atom. So let us consider the example of sodium atom. We all know that its electronic configuration is 2, 8, 1. That means the first shell of sodium atom carries 2 electrons, the second shell of sodium atom carries 8 electrons, and the last shell, or the outermost shell, so this is our outermost shell of sodium atom, carries 1 electron. If I just represent this in the atomic structure, so let us assume we have the sodium nucleus in the center, and we'll draw the first shell which contains 2 electrons. So the dot will represent the electron. Now let me draw the second shell. So second shell will contain 8 electrons. So there I have drawn 8 dots. And the final shell, or the outermost shell, contain 1 electron. So this outermost shell is what we call it valence shell. And the electron that is present on the valence shell is called valence electron. So valence electron is the electron present in the valence shell. So valence electron is the electron present in the valence shell. Now what is electronic configuration? So electronic configuration, it is the distribution of electrons. It is the distribution of electrons in the respective shells of an atom. As we have already looked at the example of sodium, so the first shell contains 2 electrons, and second shell, to the second shell, 8 electrons were distributed, and to the last shell 1 electron was distributed. So this is what we call it electronic configuration. Now to distribute these electrons, we need to follow rule, and that rule is called 2n square. 2n square. So the n here represent the number of shell. N represents the number of shell. To understand the rule 2n square followed to write electronic configuration, let us try to complete this activity together. So to understand this better, let us imagine that we have an atom which contains 4 shells. So let us say that if n is equal to 1, now we have already discussed what is meant by n. N is number of shell. So if n is 1, that means we are considering the first shell of an atom. So if n is 1, by following the 2n square rule, we can write 2 into n is equal to 1. So we'll write 1 square. So we know 1 square is 1 times 2 is 2. So in the first shell, it can only hold 2 electrons. Now if n is equal to 2, so this means second shell. This means second shell. So if n is equal to 2, by following this rule, so we get 2 into, if n is 2, we have to write 2 square. So 2 square is equal to 4. 4 times 2 is 8 electrons. So 4 times 2 is equal to 8 electrons. So second shell can hold up to 8 electrons. 8 electrons. Now if n is equal to 3, and that means we are talking about third shell. So by following the same rule, 2 into 3 square. So we know 3 squared is 9. 9 times 2 is 18. Third shell will hold 18 electrons, and the fourth shell will hold 32 electrons. So this rule, 2n square rule, will help us to write electronic configuration, and we have already learned electronic configuration is the distribution of electrons. So in this way, we'll be able to distribute electrons. Now let us try to understand the term periodicity. So periodicity means the repetition of the similar properties of the elements after a regular interval of time in the periodic table. This periodic table, the elements present in the periodic table, if you try to study all of these, we will observe that they show similar properties and at a regular interval of time. So let us consider group number 1, which is lithium, sodium, potassium, rubidium, caesium, francium. So if we study, we'll observe that all these elements, they tend to lose electron. And losing electron is what we call it metallic character. Or we can say the group 1 elements, they have metallic property. Now let us consider group number 17. The elements present in group number 17, fluorine, chlorine, bromine, iodine, astatine, all these elements, if we study it, we'll find out that it gains electron. In gaining electron is non-metallic character. So what we are observing here is similar. Properties at a regular interval of time. So here we can say that in the same group, we will find the elements, they have same properties. Now, periodicity is caused by the repetition of same valence shell electronic configuration in the periodic table. Now, we have already learned what is meant by valence shell electronic configuration. So, the electron distributed in the valence shell is the cause of periodicity. As we have already discussed the example of group 1 and the example of group number 17. We have seen that group number 1 elements, they show metallic character, and group number 17, they show non-metallic character. Now, the cause explains that all the elements in the group number 1, they contain or they have same valence shell electronic configuration. That means all the elements in group number 1, they have same outermost electron. They have same valence electron. They have same valence electron. So for group number 17 also, all the elements present in group number 17, they also contain same valence electron. Now to understand it more clearly, okay, let us write the electronic configuration for group number 17 to understand the cause of periodicity. So in the group number 17, we have the element fluorine, chlorine, bromine, iodine, astatine, but here we'll go till iodine. Now let us try to write the electronic configuration for group number 17 to understand the cause of periodicity. So by following 2 and square rule, let us try to write the electronic configuration. So if we just recapitulate what we have learned, if n is equal to 1, the first shell can hold 2 electrons. If it is the second shell, it will hold 8. Third shell, 18 electrons. Fourth shell, it will hold 32 electrons. So let me just write group number 17. And the elements present in group number 17 are fluorine, chlorine, bromine, iodine, astatine, but we will only write till iodine. And the atomic number for group number 17 is fluorine, it is 9, chlorine 17, bromine 35, iodine is 53. Now let us write the electronic configuration. So fluorine, the first shell will hold 2 electrons. Now the leftover electron is 7. 7 plus 2 is 9. So this is how we distribute the electrons in the respective shell. Now for the chlorine, we have 17 electrons. So let us distribute it in the respective shell. So first shell will hold 2 electrons. Second shell will hold 8. So 8 plus 2 is 10. Now leftover is 7. Likewise, let us write the electronic configuration for bromine. First shell will hold 2. Second shell will hold 8. And then third shell will hold 18. So 18 plus 2 is 20. Plus 2, 8 is 28. And we have 35. So 28 plus 7 will give us 35. For iodine, the atomic number is 53. So there will be 53 electrons. So the electronic configuration is 2, 8, 18, another 18, and then 7. So this is the electronic configuration for group number 17. If you observe all the electronic configuration for fluorine, chlorine, bromine, and iodine, the outermost shell, the electron present in the outermost shell, they are all same. So this is what we mean, same valence shell electronic configuration. So because of the same valence electron, periodicity is caused. So we have discussed the definition of periodicity, and also we have learned what causes periodicity, and also we have also discussed some of the basic terms like valence electron, valence shell, and so the rule that we follow to write electronic configuration. And also we have carried out some of the activities. So with this, we're done with the session.